Hi everyone, my name is Robert Palmér and I'm going to give you a quick introduction to what's new in SystemModeler 4. First out in our list of new features is new and improved built-in libraries. In SystemModeler 4, you'll find that we've updated the built-in Mathematica standard library to version 3.2.1, which includes new libraries and components for models of digital circuits, complex signals, heat dissipation, and more. For instance, you'll find the digital library for digital electronics, the quasi-stationary library for efficient modeling of electrical circuits with sinusoidal currents and voltages, and the fundamental wave library for modeling multi-phase electrical machines. You'll also find that the rotational and translational mechanics libraries have been updated to support thermal ports, making it more convenient to capture heat losses in your mechanical models. To find demonstrations of what can be done with all these new libraries and components, you can always check out our industry examples web pages. With SystemModeler 4, we've also introduced a major new thing called the SystemModeler Library Store, from which you can download and automatically install additional paid and free model libraries. All these libraries have been tested and verified to work with SystemModeler 4, and we're continuously working with developers to bring you new and updated libraries, as well as to make sure that these libraries come with high quality documentation and are easy to use. The libraries currently available at the store include the hydraulic and SmartCooling libraries and the BioChem System Dynamics and Planar Mechanics libraries. On the following slides, I will briefly go through the main features and uses of each library, and some of the libraries will then be demonstrated in more detail in the upcoming presentations. Once again, you can find example models from these libraries on our industry examples web pages, and some of the examples can also be reached directly from the library store. So, first out among these libraries we have the hydraulic library, which is a commercial library designed for modeling hydraulic systems in, for instance, aircrafts, cars, heavy equipment and process industries. And it includes a number of different hydraulic components such as cylinders, tanks, pipes, etc. Next we have the SmartCooling library, which is also a commercial library. It can be used to efficiently model cooling systems in, for instance, cars, heavy equipment and aircrafts, and includes components such as cooling fans, pipelines, water pumps and heat exchangers. Possible applications of both the hydraulic and SmartCooling libraries will be demonstrated by my colleagues in the next two presentations. The library store also includes a number of free libraries, and among these we'll find an updated version of the BioChem library used for modeling, simulation and visualization of biochemical reaction networks. The library can be applied in areas such as systems biology and pharmacometrics, and include common biochemical model components such as compartments, reactions and substances. Using this library, it's also possible to import and export models defined in the systems biology markup language to and from SystemModeler. To give you an example of how this library can be used, we can have a quick look at this pharmacokinetic model of an MRI contrast agent. The model can, for instance, be used to simulate and investigate differences between people with varying stages of liver fibrosis. Among the free libraries, we also have the Planar Mechanics library, which primarily has been developed to be used in teaching mechanical engineering courses. The library focuses on 2D mechanical systems and includes components such as dampers, revolute joints and wheel models. As an example, we can look at this model of a pendulum and slider crank from our examples collection. This model can also be nicely animated and made interactive using the link between SystemModeler and Mathematica. Finally, we have the System Dynamics library, which, as the name implies, is based on the system dynamics methodology. The library includes level and rate components and can be used to build socio-technical models of, for instance, energy markets, disease propagation or logistics systems. This model describing the spread of an influenza virus in a population is one example of how this library can be used. Okay, so now we have covered everything new in SystemModeler 4 related to libraries. Other important new features include an improved user interface in Model and Simulation Center, allowing for things like structuring model parameters in groups and tabs, better control of simulation settings, and selecting objects in 3D animations. Moreover, in SystemModeler 4 you'll find a completely new documentation center where you can get answers to many of your SystemModeler related questions. The documentation center includes built-in resources such as videos, tutorials, modeling advices, user guides, library and component documentation, and also the Mathematica by example book by Michael Tiller. You can reach the documentation center from the help menu in Model or Simulation Center, or you can just right-click any library or model in the class browser and view its documentation. You can also search for topics, libraries, or models directly using the search field, and you'll find that the documentation is extensively cross-linked. For instance, a very useful feature is the used in the examples and used in components sections, which gives you links to all available examples and other models making use of a specific class. In SystemModeler 4, we have also improved connectivity and deployment options. Most importantly, we have added support for exporting models using the Functional Mockup Interface, FMI, which is a newly developed industry standard for model exchange. You can therefore export your SystemModeler models to many other software systems. The integration between SystemModeler and Mathematica has also been improved and includes many new features such as functions for automatically creating SystemModeler models from equations or controlled system models in Mathematica. Moreover, SystemModeler objects in Mathematica now use model diagrams as their visual representation. Diagrams can be used together with other graphics in Mathematica, and they can also be animated to show system behavior. Both connectivity and deployment and the integration with Mathematica are areas that will be covered more extensively in the upcoming presentations. So, we have now reached the end of my presentation, and to conclude, I just want to quickly recap the main points of the things that we've looked at. New features in SystemModeler 4 include updated and new built-in libraries, as well as new add-on libraries which can be reached from the SystemModeler library store. We have improved user interface and overall performance of Model and Simulation Center, as well as the new Documentation Center. We also have FMI export to deploy models and use them in other software tools. And finally, we have deeper integration with Mathematica. I hope you'll find all these new features useful, and thank you very much for listening.